Hi, this is Elliot Haspel, and welcome to another edition of Best Practices Weekly. Today we're going to be talking about how you can use math errors to advance the understanding of math concepts for your students. And this comes from an article in Teaching Children Mathematics, in which an instructor talks about how, while as teachers we're used to seeing an error come up, especially in math, and being able to correct that in the moment, there's actually a lot of power in planning lessons specifically around math errors, when you're essentially intending for your students to show the common misconceptions that they may have and proactively address them as a way of really building their deeper conceptual understanding of what's going on with the math. And there's a framework to this with 4 different components. The first is selecting the mathematical tasks themselves. It's important that you're going to choose a problem or problems that focus on particular math concepts you're working on. And it can't just be any problem. It needs to be a problem that has multiple approaches to it and ones that's routinely going to trip up students. So you don't want to go with a really straightforward problem. You don't want to go with a problem that, students, there's only one way you could make a mistake for around it, or a problem which pretty much all of your students are going to get right because it's just too easy or too straightforward. There's an example in the article about a word problem that involves fractionally sharing 2 brownies among 3 brothers. That kind of a problem is really rich because you're talking about fractions, if you're talking about both how we express fractions, how we think about splitting up numbers into fractional parts, the conventions around fractions, lots of different things around fractions that you can get to from a word problem like that. Also, you may actually want to tweak what she calls the task features, which means the numbers within the problem, or the word problem surrounding the question of what you're actually asking students to solve, to literally provoke misconceptions. And that's not to be mean, but that's a way of actually getting more bang for your buck. That's a way of saying, all right, well, here's this word problem which would, as it's currently written, get at just how you split up fractions, but if I actually change the numbers, or if I change what the question is, I'm also going to help students have to think about the ways that you write the fractions, in addition just to what the solution should be. So that's what she means by tweaking them. Next, you need to actually plan for instruction pretty strongly. This is an important part. First of all, anticipate the most common misconceptions that will arise. Take a look at the problem, think about, what have students in the past had problems with. The internet can be good for this if you're not sure, but really plan, this is what students are very likely going to do wrong. And there are also 2 essential elements to plan for. One is ways for students to actively engage in attempts to unpack the mathematics underlying the errors, which means students should get some sort of opportunity to work on these problems either on their own, in pairs, in groups, and they should be asked beyond just solving the problem. So they need to be asked in some form to justify their answer, write down why they think they're right, or write down another way you could have gotten to that answer. Things like that, which are going to actually force students to think one layer beyond just what's the answer to this question. And second of all, the teacher is going to need to facilitate a public class discussion of the ideas in a way that the key concepts are emphasized. So again, when you're having class discussion, and more about this later, you're not just going over, well, here's what the wrong solution was, and here's what the right solution should have been. Because that doesn't actually convey the key points, doesn't actually convey the concepts that are underlying why the misconceptions are there in the first place. And so to dive a little bit deeper into that, the third part of the framework, when you're actually implementing the lesson, that first half of the student work. So you're sending the students to work on these problems on their own, in pairs, in groups, whatever you want to do. Be sure as the teacher you're going around to the students, you're checking in, you're listening in, and you're looking at their work. You're getting a sense of what errors are actually surfacing. Are they the errors you expected? Is there a new error, a new misconception that you actually didn't expect them to come up with, that you have to sort of on the fly think about, okay, what are they thinking that's causing them to come up with this wrong answer? And then select a few students who are showing the examples of the really common misconceptions and ask them if they'd be okay with sharing out to the class their solution. And this is important that you're doing it, obviously, delicately. You're choosing students who you think would be comfortable doing this, and that you're framing it as, this, you tried really hard, this isn't the right answer, but actually it's going to help the whole class if we talk about it. So do you, be willing to help out, make it something special for those students. And then move on to the fourth part, which is the public discussion. And when you're planning for doing this public discussion, a couple of things you need to do as the teacher to get ready for it. First of all, as you're going around the class, think about who has the wrong solutions, who has the right solutions, and which are the ones you're going to choose to talk about. So there might be a student who came up with a wrong solution that is just like way out there. Like, this is a total outlier. It's not a common misconception. That's probably not the student who you want to have presenting. That's probably not the solution you want to talk about as a class. You want to figure out who had the wrong ones that are very common, who had the correct solutions, who seems to really be able to explain it, who showed their work, things like that. Think about the order and the way in which you're going to present the solutions. Do you want to go with the wrong solution first, and then the right solution, and then the wrong solution? How are you going to present it? The teacher is totally welcome to present the solutions also themselves. The teacher can say, I was working on this problem, and this is the mistake that I made. So how are you going to present them? Are you going to have the students explain it themselves? Are you going to take the students' work and explain what they did? Just think through those sorts of things ahead of time. Whatever makes the most sense for your context, for your grade level, things like that. Your students. And then think about the concepts that each solution is intended to demonstrate. What that means is, again, if you look at a common mistake, you're thinking about why did that mistake happen, and what's the concept that the students didn't understand in order to make that mistake, which you can correct by talking about it as a class. So is it that students didn't understand that when you're splitting up the fractions, they wrote the denominator and the numerator in the wrong order, right? And why did they do that? Did they not actually understand what the numerator and what the denominator is? That would be a concept which you would want to illustrate using that example. Things like that. And then it's also important, you can probably tell, that in this kind of a lesson, you're going to have to emphasize a culture of mistake-making, a culture of respect, that mistakes are totally, that they're good things, actually, that we can learn from them. As a class, we, work together, we're a team, all of these things, so that students who are making mistakes aren't feeling in any way insulted or bad about themselves for making mistakes. So, again, this is a framework for really thinking about starting from a place of the errors and misconceptions that students make, rather than waiting until they make them and then trying to correct them, which is a powerful way to try to build students' deeper conceptual understanding and critical thinking skills in these areas of math. So, thanks for watching, and happy teaching!